Welcome to aminacademy.com. In mathematical formulae and their explanation, let us discuss about formula for partial derivatives. What is partial derivative? A partial derivative of a function of several variables is its derivative with respect to one of those variables with the other held constant. That means you have to differentiate with one variable keeping other variable constant, as opposed to the total derivative in which all variables are allowed to vary, but here partial derivative only the particular variables are differentiable. Now let z is a function of f of x comma y be the function of two variables x and y. Then we define the partial derivative of z or f of xy is dou f by dou x, dou f by dou x, dou f by dou z. Here in that dou f by dou x, but the variable is given in terms of z is the function of f of x y. We have to find dou f by dou x. That is, it is a definition is limit delta x tends 0 f of x plus delta x comma y. That means variable x only changed, small increment, minus f of x comma y over delta x. This is the definition for partial derivative. Similarly, dou f by dou y is limit delta y tends 0 f of x comma y plus delta y minus f of x comma y over delta y. Now this partial derivative is also denoted by dou z by dou y or f of y zy like. Now further the continuation, look at here. Dou square f over dou x square, which means second derivative of dou f by dou x with respect to x. That is, dou square f over dou x square is dou x of dou f by dou x. Similarly, dou square f over dou y square equal dou by dou y of dou f by dou y. Another one, dou square f of dou x dou y. What do you mean? In that, here a second derivative of y with respect to x, which means dou by dou x into dou f by dou y, and another dou square f over dou y dou x, which means dou by dou y with respect to dou f by dou x. Like that we can expand. Next one, look at this example. Partial derivative of first order. For example, f of xy is the function 3x square y minus 2 plus y cube. How to find f of x? Here f of x means dou f by dou x. We have to differentiate this function with respect to x, other things keeping constant. Here 3x square y, here y is a constant here, so 2 into 3 is 6xy. Here 2 is 0 and y cube differential also 0. We have two constants 0. Therefore, f of f fx, that is partial derivative with respect to x of this function f is 6xy. Similarly, f of y, keeping y x as a constant, y is a variable. Here x is a constant, means 3x squared is a constant, so it comes differential of 3x squared y is 3x squared, and 2 is a constant, so it becomes 0, and y cube differential is 3y squared, partial derivative of f, that is f of y, fy is 3x squared plus 3y squared. Now for compute f of function is f of xy, that is we can find, look at here, f of xy, the function is 2x plus 3y minus 4. Calculate fx, that is dou f by dou x is here. Y is a constant. Yeah, y is a constant means these two things constants. So fx is 2. Similarly, if y is 3. Now look at this. Here dou by dou x of dou f by dou x is dou f square f over dou f square. We can write this way, f of fx and x, that is fxx. Similarly, we can do the partial derivative of dou by dou y of dou f by dou y is dou square f over dou y square. Look at here. This is important formulas. Next one example. Look at here. If f of x comma y is 2x square minus 4x minus xy squared plus 2y squared minus 3. We have to find dou f by dou x. Dou f by dou x is with respect to x we have to differentiate, other things constant. This is 4x. And then with respect to x, the differential of minus 4x is minus 4, and differentiation of xy square is y is a constant, so xy square differentiation is y square. Like dou f by dou y is minus 2yx plus 4y. Then dou square f by dou x square. That means this we have to differentiate one more time with respect to x, becomes it's 4, because other thing is constant, keeping constant. Then dou square f by dou y by dou x is dou by dou y of this function. Differential with respect to y is keeping y as a variable, other things constant, so 4x and 4 becomes 0, y square becomes minus 2y. Minus 2 minus y square is minus 2y. Then similarly, dou square f by dou y square, which means we have to differentiate this with respect to y one more time. So means x is a constant, minus 2x comes here. And dou square f by dou dou y is dou by dou x of minus 2yx plus 4y. Here we have to differentiate this function with respect to x one more time. It becomes minus 2y. Look at here, in general figure here, f of z equal to f of xy, we can find dou f by dou x, dou f by dou y. And from that is called fx x comma y. Here dou z by dou y, fy xy. Further, it can be differentiated with respect to x itself. It becomes dou fx by dou x. Here dou fx by dou y. Here also we can find second derivative, that is dou fy by dou x, dou fy by dou y. So this together we can write the differential of the same variables fxx xy. Here fxy means differential of y with respect to x. Like we can combine figure, this better to remember. Next, Euler theorem's formula. A function f of x comma y will be a homogeneous function in x and y of a degree n if f of tx comma ty is t power n f of x comma y, which means the partial derivatives of a function, if you give multiply with some parameters t of both variables, it becomes t power n and f of xy, where n is the degree of that polynomial. Following are the Taylor's theorem formula for 2 and 3 variables. Look at here. The 2 variables u is a homogeneous function and x and y of degree n. Then the Taylor's theorem says x dou u by dou x plus y dou u by dou y equal to nu. Nu means degree into that function. It's a Euler's formula. For 3 variables, u is the homogeneous function if 3 variables x, y and z of, that is x dou u by dou x, y dou u by dou y plus z dou u by dou z equal to ne. Let us do an example problem to understand this concept. Here, for Euler's theorem, we will solve something. If f of x, if f of x comma y is, the function is log of x squared plus y squared over x plus y. By Euler's theorem, we have to prove this Euler's theorem, that is, let e of u, that is, logarithm becomes e power function by using this way. E power v is x squared plus y squared over x plus y, which is f of x comma y. Therefore, f of x comma y is, we are multiplying with consider lambda is a parameter, so lambda square x square lambda square y square over lambda x plus lambda y, which is equal lambda, because here lambda square take out common, here lambda is take out common, then it becomes x square plus y square over x plus y. Therefore, f is homogeneous function. We can let by theorem, by Euler's theorem, the Euler's theorem, x dou f by dou x plus y dou f by dou y equal 1 into f, because degree is 1 here, degree is 1, therefore 1 in n into f, 1 into f. Then fx dou f by dou x into e power x plus y dou f by dou y e power v equal to e power e, because this dou f by dou x plus dou f by dou y equal to f, so e power v comes, it exists. Therefore, we can say x dou f by dou x plus y dou f by dou y equal e power v over e power e equal to 1, hence proved. That means we proved x dou f by dou x, y dou f by dou y equal e power v over e power v is 1, hence we proved. Next is multivariable differentials. Here differential of z differential of z equal f of x comma y defined as, look at here, dz. Differential dz is dz equal df, which is equal dou f by dou x dx plus dou f by dou y into dy. This is a differential of z, or differential of f is equal dou f by dou x into dx, dou f plus dou f by dou y into dy. Now, for example, if z equal x square plus 5xy plus 2y square, then zx. Then zx means partial derivative of x with respect to x. Partial derivative of z with respect to x is 2x here plus 5y. Then and zy equal to 5y. Then differential of 2y squared is 4y. We got zx and zy. Then dz, differential of z is, zx is 2x plus 5y into dx plus 5y plus 4, 5y plus 5x here. Five x plus 4y. Into dy. Therefore, now put, suppose dx equal to 3 and dy equal to 4. Find the at point, not at point P of 6 comma 2. We have to substitute x equal to 4. Therefore, x equal to 4, x equal to 6, y equal to, and substitution, like this is dz is 2 into 6 plus y into 2, dx is 3 plus 5 into x is 6 plus 4 into 2, y is 2 and dy is 4. We have to calculate this differential of z is 12 plus 10 is 12 plus 10 is 22. 22 into 3 plus y 6 are 30 plus 8, 38 into 4. Here 66 plus 152. So here, which is equal, then 8, 11, 18. So far we discussed about partial derivative with higher order, single partial derivative and higher order partial derivatives, as well as Euler's formula and some examples. We have done. Please subscribe our YouTube channel.